Welcome back to the Printasaurus. I'm Aaron, and what I have here in my hand today is the stock inductive probe that comes with our SV08. We are going to toss this guy aside, and I'm going to walk you through everything you need to know to upgrade to the Eddy USB. So follow along, we're going to jump right into it and get this thing set up and printing perfectly. So in order to upgrade to the USB Eddy, there's a couple things that you're going to need to do first. The biggest one is making sure that your SV08 is on Mainline Klipper. I did a video on that about 2 weeks ago if you need to reference that to get upgraded. And the reason why is because the Sovol fork does not support the Eddy USB. So that's your biggest upgrade that you're going to need to do to prepare for this. And then we're going to need to print some parts. We have to print a mount for our Eddy USB because we have to remove it from the stock housing. This needs to be printed in ABS or ASA. Do not use PETG or PLA because it is in an area, it's next to the nozzle, it's close to the bed, it's an area that is exposed to a lot of heat. So use a stronger, more resilient material, ABS, ASA, nylon, something along those lines that can take quite a bit of heat. Links to that is down below as well. This mount was made by Rappetor from Printables, so check that out. You'll also need some screws, 2.5 millimeter by 4 millimeter for this mount, and that's just to fix the Eddy to the actual mount. I bought a kit on Amazon that I have here. It was like $8, and this goes from M1 to M3 screws of all different sizes and ranges. So please take a look at that if you need to source screws and you don't have a local hardware store to do that. Something else that you can use, it would be an advantage. So when we get to the calibration step, you will need to set the Eddy coil 20 millimeters from the bed surface. So I use calipers. They're obviously more accurate. If you don't have that, a ruler will work. And you can also measure an object. If you have something, this is a Lego Duplo that actually happens to be almost 20 millimeters. So this would also be a good reference. If you have kids or something, hey, maybe you got something around the house that measures out to be 20 millimeters that you can just set on the bed for that process. So that will be down the line here. First thing up is actually getting the Eddy coil mounted. So we're going to move into that next. So to mount our Eddy coil and our printed part, we need to remove it from the stock housing. So I'll show you here. This is the stock Eddy coil housing. And what we need to do is remove it. So the easiest way I found to do this, I'll press it back in place. Mine's already removed. But the easiest way to do this is to take an Allen key of some sort, and you have these through holes for bolts. If you stick one in there just a little bit, you can actually just pry this open. So stick it in there and then it pops right out, and you can remove your Eddy coil and then take it and set it on your mount and 2 screws and you're good to go. So let's go ahead and move on to installing this. So to start this install, what we need to do is remove the tool head cover here. It pops off, it's just held in by magnets. And then you'll see here your fan is connected the upper right hand corner. It's glued in place, so just gently pull on this and pry. You can peel the glue too, but just pull on that ever so gently, holding the connector, and remove it and set it aside. Now I already have my stock probe removed, but I'm going to show you where that would have been. So here's the screw hole where that stock probe mounts, and it's a 2.5 millimeter Allen key to remove that. And then up here on the left side here is where it plugs in. So you'll need to remove that as well. And again, that's held in with a little bit of glue. So we have our Eddy printed here. I'll show you. So here is our Eddy USB, and it is in our printed, and ABS is what I used, is our mount. So our mount has a reference point on it, and then it has a through hole for a Allen bolt that I just dropped on the floor. So let me grab that. Okay, we're back. So drop that screw in there is the easiest way to do it. And there's a little pinhole kind of on the back of where the nozzle is, and that's where that little registration pin goes in place. So what I did was just kind of take this, and you can kind of float it around till it finds that spot, and then you can kind of manually thread. I used a 10mm long Allen screw, bolt, whatever you want to call it there, to attach this. So you want to tighten this, but don't over tighten it. So what I do is I snug it, and then once it's snug, I give it about another half turn. And that is plenty for it to be in place. And then for cable management, this is the USB. What I did for the time being, in case we need to troubleshoot anything, is we're running it to the external USB port on the side. Now you could run it there permanently if you wanted to, but we're gonna actually run it through and then down inside the printer here later in the video. But for now, we have it connected externally. So you can just kind of run this cable down, plug it into our tool head, so it plugs in here. Make sure that is pressed in place securely. Now, I want to note there's a little button here on the top. So that's going to be important later. So we leave our fan shroud off for the time being so that we have access to that button when we need it. But you can kind of tuck this in behind this cable for the time being. And then when we are ready to put the tool head cover back on, it kind of keeps that out of place and you don't have any issues there. So we'll take this back off, set it aside. Okay, so we have our Eddy installed. We have the USB RAN. Like I mentioned earlier, I just run it to the external for the time being. We will clean this up and use the existing cable management to kind of run this through, and we'll run it to the inside of the printer and connect it internally once we have everything configured, everything set up appropriately. So next up, we need to compile the firmware that's actually going to be flashed or uploaded to the Eddy to make it work with our printer. So we're going to jump on the computer now, and I'm going to walk you through on screen how to do the next few steps. We are going to use terminal. For me, you might have putty. Whatever you have, what you want to do is SSH into your printer. So once you've SSH'd into your printer, we can copy a few commands off of the BigTreeTech Eddy GitHub. And that first command is a cd to the Klipper directory. So you'll cd ~Klipper. And then here what we're doing is we're checking to make sure that we are on Mainline Klipper. So you'll get checkout master and hit enter. And it will tell you you're already on the master branch. So we are on Mainline and we are up to date. If there were any updates, it would pull down the updates there. So we are good to go there. We verified we're on the right version of Klipper. If you were still on the Sovol fork, this would not work, which is why we needed to upgrade to Mainline Klipper. So now we're ready to actually make our menu config, which will be our firmware configuration. So we're going to cd back to ~Klipper. And that's, you're already in that directory, but we'll just type it out anyway. And then now we need to do a make menu config. All right, now when this comes up, there's a couple of options you're going to need to do for the Klipper firmware configuration. So the first one you want to do is enable extra low-level configuration options. And then we're going to check our microcontroller architecture, which is the next one. You want it to be Raspberry Pi RP2040. So if it's not, hit enter on that one and then use your arrow keys to navigate down to Raspberry Pi RP2040. Once you've done that, you can hit escape. That's going to bring you out. And that is the only other thing that you needed to do. You want to make sure your process model, again, is RP2040 and no other options. USB serial for communication would be the only other important one. So we've got everything there, so we can hit Q, and then you would hit yes to save. So at this point, we are ready to make our configuration. So you would simply type in make and let that run through and make your software. In my case, because I've already ran through it, it will say there's nothing to do, but yours will scroll through and do a computation or compile that software. So once that's done, we are ready to power on our Eddy. initialize it so that we can actually flash it. So to do this, unplug your Eddy from the USB, and that button that I mentioned on top of the printer, so your button here, what you do is hold that down, and then you're going to plug in the USB, and then once you do that, it's going to put the Eddy USB into the initialization mode so that we can actually upload our firmware. So we're going to SSH back into our printer, and we need to type ALS USB. What that does is it lists all the USB devices, or the USB devices that are plugged into your printer, and you will see a ID, a device ID for a Raspberry Pi RP2 boot. So we have it in boot mode, and we know that it is a Raspberry Pi RP2 because that's what we told it to be in the firmware. That's what we wanted. So you need to take that device ID, and we're going to copy that into a command. Make sure that you are CD'd back into that Klipper directory, so CD ~Klipper, and then we're going to run the command make flash. So we're going to do make flash, and then we're going to do in capitals flash underscore device equals, and then you will type out what that device name was or paste and hit enter. And what this is going to do is it is going to flash your USB Eddy. And then once that is completed, now we can look to see if we have it correctly identified. So to do this, you can do an ls dev serial by tac ID and then a asterisk. And that will list all your devices. You'll note that you have 2 on the STM32s, so that is your tool head and your main board. And then now you should also have a USB Klipper RP2040. That is your, you guessed it, your Eddy coil. So what you need to do there is copy that device name. I copy the whole thing because now we need to paste that into our Eddy configuration on our actual printer so that the printer knows what to communicate with in order for that probe to work. So go ahead and copy it now. That way it's copied, and then all we have to do is paste here in the next step when we get into the printer configuration. Today's video sponsor is PCBWay, PCBWay.com. Please check them out. If you jump on their website, they offer a number of services: injected molding, CNC, sheet metal, and FDM, resin, you name it, they offer some sort of 3D printing service. Customer service is great. If you need to order large quantities, they can help you there. Shipping is pretty quick, and their quote responses are also very fast. So please check them out. They are a great resource. Website is laid out very well, and customer service is even better. So check out PCBWay.com. All right, so we are in main sale. We're going to go down to the machine tab. We're going to go ahead and click on that. Then we're going to navigate to the printer CFG. So we're going to move down to line 17, and we need to comment this one out. This is include options probe stock CFG. So this is a stock configuration for the standard probe. We no longer want to use that, so put a hash mark there in front, which comments it out. And then we're going to uncomment line 18, which now includes the options probe Eddy config. So once you do that, we are going to scroll down a bit further and go to line 253. So we need to remove lines 253 to 262 and comment all those out when we are using the Eddy probe, and that's because these are the standard offsets for the traditional probe, the probe pressure, and its pin that it uses there on the tool head. So we don't need any of this information anymore, so we're just going to comment it out. And that concludes what we need to do for the Eddy configuration in our printer config. So now we can do a save and restart. And then next up, we are going to, when your printer comes back up, make sure you are back in your main sale, click on your machine tab again, and now we are going to go to our options folder and then down to probe. So here you would have the stock config that you were using. So you may or may not have your Eddy config in this folder already when you did your mainline upgrade to Mainline Klipper. So if you don't, you would simply go to Rappetor's GitHub for those instructions. Those links are down below, and we would just navigate to the config folder and then options and probe. And then here we have that Eddy CFG, so you could simply download this and we would upload it using the upload file under the options probe folder. And once we do that, we will open up our Eddy config. So here is where earlier we copied the device serial number of our Eddy USB, and this is where we're going to need to paste it. So on line 17 here, you have serial dev, and then it stops at RP20. 40 underscore. So paste in that serial number. I copied the whole path, and then I just delete it till it looks like, you know, something similar that you see here. So that's going to be unique to your Eddy that you're using. So just make sure that you're referencing this as a guideline, but you are inputting your information there. So once you do that, you have one more thing you need to change, which is line 26. So your probe Eddy current BTT underscore Eddy. I'm sorry there. It's been a long day. So we're going to change our X offset. And this is because of the mount that we're using for our Eddy. It is version 3 of Rappetor's mounts, and that one had a slightly different offset that was to be used. So we're going to change this to -16 instead of the -16.5. So make sure you make that adjustment. And that's it for in here. If you want, all the way down at the bottom, I believe these are commented out. So if you want to add a bed mesh calibrate before each print, simply uncomment those, and then that enables that option. So you are good to go now if you have your device serial number here and you have that X offset set to a -16. So save that and restart. And now we are at the exciting part. When this comes back up, we can go back over to our dashboard. And now we're going to utilize the console over on the right side. Well, at least it may be on the right side for you. For me, it is. And we are going to type in some calibration commands, and we are going to start dialing in this printer and getting it ready to do a first layer test and then print some other things to make sure things are working the way we want them to. So this is the fun part. We are almost finished. The first thing we need to do is remove our fan shroud again and just disconnect that fan and set that aside. And then what we're doing here is our Eddy coil is mounted, and the first calibration we need to do is a drive current calibration. And this is where the Eddy coil needs to be 20 millimeters from the bed surface. I mentioned earlier you could use Lego Duplo, you could use calipers or a ruler, anything you have that can measure out 20 millimeters. So I found the easiest way to get this set up is make sure your printer is off, because you're going to have to manually move the gantry up and down. But if you work from the back and then work from the front, work from the back and then the front, it's much easier to push down to get it in place than it is to pull it up and get it in place. So I'm going to show you a close-up of how I did that. So we can see our Eddy coil here. It's mounted in place. Everything is ready to go. So we need to get this 20 millimeters from our bed surface. Be careful not to scratch your bed surface with whatever you choose to use. So I'm going to use calipers at first just to show you. So here you can see we are a little bit off. So this is where we can push down on our gantry slightly and try and keep this level. It just makes it a little bit easier to move around. And then we will check with our calipers again to see how close we are. Okay, so we're going to continue to press down. We are very close. All right, so we are now lined up with what we want, which is 20 millimeters. So once we have that set up, what we need to do next is jump over to mainsail. All right, so we have our printer turned back on. We have our Eddy USB set to 20 millimeters. Now we're going to jump on the computer and we are going to navigate to the mainsail dashboard. So type in your printer IP in a web browser and we are going to go to the console. Now in the console, we are going to type in LDC underscore calibrate underscore drive underscore current chip equals BTT underscore Eddy. And what this is going to do is a drive current calibration. All of these steps will be down below in my description so you can copy and paste as you follow along. So we will hit enter on that. And then your probe is going to come back with a drive current reading. Mine was 15. So next we are going to do a save underscore config, and this will save that configuration. And restart your printer. All right, so the next step is similar to what you would do for a Z offset calibration, a probe calibrate. This one is for the Eddy coil though, so there's a couple of different parameters there. So you will need a piece of paper you're going to put under your nozzle, and then we are going to go back to the console and we are going to do a probe underscore Eddy underscore current underscore calibrate underscore auto, and that chip will equal BTT underscore Eddy. Again, these are all down below in the description, so feel free to copy and paste. It will make things easier. But we are going to paste that in the console and press enter. And this is going to more or less home the nozzle, and then we will do a manual probe calibrate with that piece of paper. And what we're looking for is slight tension on the paper. It doesn't need to be to the point where you can't move the paper at all, but you will adjust your Z offset now until you have that tension on that paper. So we are going to move down. You can eyeball this to an extent, and then when you get close to the paper, you will want to kind of move the paper back and forth and make sure that you are getting it appropriately tensioned. So here you can see I can still move that paper. We're getting closer. All right, so at this point we went too far, so we will raise it back up. And then now we will start micro stepping further to get that lined up. So take your time with this, kind of go back and forth. So now we have some slight tension. That is pretty good. So now we can pull that paper out and we will hit accept. And then once we've done that, what we want to do is a save underscore config after it runs through its calibration. So now it is testing that offset. It's going to do this multiple times. It takes about 20-30 seconds or so. So let it do its thing. You will do a save config here. So save underscore config, we'll set that. Your printer is going to restart again, and then we will move on to a bed mesh calibrate next. All right, so our printer is back online and we're going to do a bed mesh calibration next. And in order to do that, we need to do a quad gantry level. So go ahead and do that. So our quad gantry level process just finished up. And the next thing we would want to do is home all axes. So hit the home all. And what we're doing there is just moving the probe back to the center of the bed in its home position. So we can do the bed mesh calibration next. Okay, so at this point we're ready to do our bed mesh calibrate. We are ready to type in our next command, which is bed underscore mesh underscore calibrate, and that method equals rapid underscore scan. Again, this is down below in the description, so please feel free to copy and paste. But at this point we did our quad gantry level just to confirm, and we homed all axes. If you look at your printer, everything's in the center of the bed. We're now ready to hit enter. This is going to do a rapid scan for the bed mesh calibrate. It's actually pretty neat. Okay, so the bed mesh has been completed. It is saved as the default profile now for this current session. So what we want to do now is a save_config again, and that will just save that setting as our baseline mesh here. So go ahead and save config. Your printer is going to restart again. And the next step, which is the final step in the calibration process, will be a temperature compensation calibration. All right, so we are on the last step of the calibration. This is the temperature compensation. So what we need to do first is home all. So go ahead and hit your home button. And then in our console, we are going to type G0 space Z5. And what this is going to do is set the Z to 5 millimeters. And then once you've seen that adjustment, the next thing we are going to do is set a timeout command. So you're going to set _idle _timeout, and that timeout is going to equal 36,000. One last time, all of this is down below in the description, so please copy and paste as we go through and I call out these steps. So you set your idle timeout, and the next one we're going to do is what's going to start this probe calibration process. And that one looks like this. It's called temperature _probe _calibrate. That probe again equals BTT Eddy, and then you have a target range set and then steps. So one last time, this is down below in the description. Please copy and paste, but go ahead and hit enter. It is going to prompt you to do a manual probe again at this point. So this is where that piece of paper will come into play again. And what you're looking for is that same amount of tension that you set earlier in this process. So go ahead and step down your nozzle. Be careful as you get closer that you don't overdo it. We don't want to mess the bed up or your nozzle. All right, and then now we are pretty close. So now we can micro step from here to fine tune it. All right, and then once you have it where you want it, go ahead and hit accept. And then now what we want to do is what it's looking to do is increase the temperature of the BTT Eddy or Eddy USB. So what we want to do is we want to give it a way to do that. So in order to do that, we need to increase the heat of what we have. So set your extruder temperature to 220, and then set your bed temperature to almost your max. So in this case, our SV08 goes up to 100, so I'm going to do 95. And be careful for these following steps, because this stuff is going to get hot and you will still have to use that piece of paper, so you can burn your hand a little bit there on the bed. Things get pretty hot pretty quick. But for this step, what we need to do is you're going to look for that temperature increase, and then it is going to prompt for another manual probe. And then once it does that, it will do one more cycle of that. So our next range is 46 degrees Celsius. And if you look at your temperatures on your screen, you'll see that BTT Eddy slowly rise as the temperature of your build plate and everything rise as well. And you know, this step really is important because it does help with temperature variances. It's, you know, an effort to improve your probe quality overall and just give it a more granular calibration. So it just gives you more input there, which increases the accuracy of your probe overall, especially with heat, because heat can change all kinds of stuff. Your bed becomes unlevel, your machine expands and contracts. So there's all kinds of variables, and this is just a nice calibration step that helps there. So we've hit that next range. So now we can put our nozzle underneath, or our piece of paper rather, underneath our nozzle, and things are getting pretty hot. So again, be careful with your fingers. And then here we are just going to step this down again. And what we're looking for is that same range of tension that you had set on the last probe. So what I do is I pick up the corner of the paper just so my hand isn't on the bed because this thing is hot. All right, so that looks pretty good. So I'm gonna pull my paper out and we're gonna hit accept. And then we have one more probe point we're gonna do, which is 57 degrees Celsius, I believe, is what the next one is. Or 54 is what it comes up as. So our Eddy is at 53 now. So we are almost to the last calibration point, and then we can move on to, we'll do a first layer test. I'll show you that so we can see what our first layer looks like. And then we will move on to, I'll print something simple so you can see it. But at that point, you're ready to go. You're ready to start using your printer. It's important to note, I was bad here. I left some filament in my printer. You definitely don't want any filament in when you're doing this process. If you already have some in there, you're probably going to experience the same oozing that I'm having now. So just, you might have to restart that process. Sorry, I didn't mention that earlier. All right, so we are going to dial this in now. Things are getting hot. It is really hot. We are getting close. All right, so we have it where we want it. We're going to accept it. And this should be the last probe point. So now it is doing its calibration again. And now we can do a save config. So save_config, enter. Your printer is going to restart again, and then now we are ready to put our fan shroud back on our printer, and we are ready to start printing. So at this point, our configuration is completed, our calibration looks good, and we have moved on to testing our printer. I have a first layer print finishing up now. Once it's completed, we'll pull it off and take a look, see what it looks like. So this is finished now. So it's not going to be cool, but we'll pull it up if we can. Not bad. So we're going to continue to do a couple of test prints. I'm just going to print some small things, see what it's like, and then I'm pretty much going to just roll into printing some projects and whatnot that I've needed to get done with this printer. So at this point, you should be good to go if you had issues. So if your first layer didn't turn out well, what I would suggest to do is to go back through the calibration steps. You don't have to do the drive current calibration, but redo your probe calibration, redo your temperature calibration, and then see what you end up with. So you saw the close-up of the first layer. I did reprint this just to make sure that it is repeatable. That was an issue I was having with the stock inductive probe, was when you turn the printer off, turn it back on, it didn't appear to keep the Z offset accurately for whatever reason there. So repeatable, it worked, no issues with that, which is great news. The second thing that I printed was this leaf, Lego leaf. And all in all, same deal. No gaps between the walls and the first layer, so things turned out good there. And then you'll see here the infill and everything else printing and everything doing what it's supposed to do. So turned out great. No issues with that one. The Eddy probe seems to be better than the stock probe. We're going to continue to fine tune and do some further testing, and I will share that stuff with you moving forward. Coming up next for the SV08, I'm going to do a nozzle upgrade as well. So look for that video coming out shortly. And that will be the next planned upgrade. And then, like I mentioned, we will revisit the probe, see if we needed to make any additional changes as we discover new things as we continue to print with it. But I wanted to get out the initial configuration, so that's what this video is. It's how to install it, get it set up, and get you up and printing again. For your cable management, I kind of left that up to however you want to do it. Internally, on the main board, there is an open USB port. So if you want to route it down using the same routing as the stock wiring harness coming from the tool head, that works. That's what I ended up doing. But if you also want to just leave it connected to the external USB, you're free to do that as well. So down in the comments, let me know what you guys ended up doing for cable routing. Maybe I'll steal one of your ideas to kind of pretty up my setup. But please like, subscribe, comment. Love to hear from you guys. Let me know what you guys are printing with your SV08. Let me know what other issues you're having with it, and then maybe we can do some videos on addressing those. So happy printing, and I will talk to you guys in the next video.